Welcome to NASA STEM EPDC Quick Bits Big Ideas in Science Content. NASA STEM Engagement and Educator Professional Development Collaborative provides NASA resources and STEM strategies for STEM engagement. In this series, we intend to reach educators, parents, and caregivers to quickly explain a specific big idea in STEM. We will introduce a NASA example of how this idea is applied in the real world, and finally, we will demonstrate step-by-step how to lead this activity at home or in the classroom with your students. You might invite your students to watch with you at that time. We invite you to join us as we learn more from our specialists. Let's get started.
Hello, my name is Susan Kohler, and I am an education specialist at Glenn Research Center in Cleveland, Ohio. Today, we are going to explore the Scoop on Soils. It is a storybook elementary globe designed to introduce students of grades K through 4 to the study of Earth system science. It is available in 5 languages. The science content provided in the books provides students with a meaningful introduction to technology, inquiry, and connections to math and literacy skills. Each book has associated hands-on learning activities to support learning exploration. What is the big idea? The big idea provides a basis for setting curriculum practices. What do we want them to take away from this experience? And why is NASA collecting data? They're collecting data to help study the moisture in soil. This helps scientists predict floods, farmers to grow more crops, and for communities to plan for drought. NASA also uses this soil data to size up floods from space. What can we learn about some of the relationships between different types of soils and water? As the Earth experiences global climate change, temperatures are rising, and this is causing some places to get too much water and some places to not have enough. NASA Global Climate Change, Images of Change, captured the evidence of the damage to Puerto Rico's forests during Hurricane Maria in September 2017. What do you see when you look at the before and after images? On the left-hand side, you see how lush and full Puerto Rico's forests were before the hurricane. On the right-hand side, you can see that these forests were devastated, and you can now clearly see the road and the brown of the soil where the trees were ripped away. NASA doesn't study just the stars and planets. It is also concerned with the soil beneath your feet. Studying the moisture in the top 2 inches of the soil from space with a satellite named SMAP can help weather forecasters predict flash floods and droughts.
Did you know that soil under your feet contains some of the most important water on Earth? And keeping track of this soil moisture is an important mission for NASA. Think of soil as a sponge. It can absorb a lot of water, but will eventually become full, or it can dry out as the water evaporates. Knowing when the soil is getting too dry helps us plan for droughts, prepare for food shortages, and identify places where wildfires can spring up. Knowing when the soil is too wet and can absorb more rain helps us better predict floods and landslides. The best way to monitor soil moisture is not from the ground, it's from space. So NASA does this with special instruments orbiting high above us. Tracking soil moisture from space helps us improve weather forecasts and climate models. And it helps farmers know when to plant, water, and harvest their crops. Everyone on Earth benefits from the study of soil moisture. It's one case where NASA dishing the dirt is good for all of us.
Let's return to the Scoop on Soils and find out what happens in the story. In this story, Dennis's dog, Scoop, likes to dig holes in the soil, and he is on the loose. Simon, Anita, and Dennis set out to look for Scoop as he digs holes all over town. Along the way, they discover just how special soils are. As the students search for Scoop, they discover that he has visited many places in the community. He has dug a hole in the forest, he has dug holes in the meadow, and can you believe this? He dug a hole in Mrs. Chang's garden. Not all soil is the same. Soil comes in many colors. Some soil looks and feels different than other soils. The color and the feel of the soil often changes as you dig deeper into the ground. You can learn a lot by seeing and touching soil. In a way, soil is like a secret decoder. The students explore the various sites and collect soil profiles. They draw the soil profiles in their science journals. Most soils come from rocks. Over many years, weather causes rock to break apart, and the pieces get smaller and smaller as time goes on. Soil forms when bits of rocks mix with things like dead leaves and even dead bugs. The students sketch a soil comparison chart in their science journal. The feel of the soil can tell you about its ingredients. Soil contains many different amounts of sand, silt, and clay. Soil in a forest might be gritty, which means more sand. Soil in a meadow might be smooth, which means more silt. Soil in a garden might be sticky, which means more clay. Have the students collect the soils they will test. Lay the different soils out on a tray to observe. You are going to want to have some gravel, some sand, and some soil from their own backyard. What do we need to do this experiment? The first thing we need is something to measure with. You will need a graduated cylinder or a measuring cup to measure the water. Next, you will need something to measure the soil samples with. You can use measuring spoons or you can use dry measuring cups. You will also need 4 recycled water bottles. Really, any size will do, but I'm using the 500 milliliters or 16 fluid ounce bottles. You will also need something to make a filter. I'm using gauze bandages. They're fairly inexpensive and I can get them at Dollar Tree. You can also use coffee filters, cheesecloth, or anything else with small holes in it. Then you will need rubber bands to fasten the filter to the bottle top. You will want some different types of soil to test. I've used gravel. You can use gravel from an aquarium store. You can use gravel from the yard. You can use gravel from almost any place you can find it. And you will need some sand. You can get sand at the hardware store relatively inexpensively. I'm going to use 2 different kinds of soil. One is a potting soil mixture that you buy in the bags. The second soil sample that I'm going to use came from my yard. Take each bottle, and what you're going to do is remove the cap. You don't need the cap. Cut the bottle in half. Then you're going to invert the top of the bottle into the bottom, forming a catchment basin for the water. Next, you're going to take your gauze or your filter and put it over the top of the bottle and secure it to the bottle with the rubber band. This will keep the soils from falling down into the water in your catchment basin. Take 60 milliliters of gravel and put it into the top of your container. That is 4 tablespoons. In the second bottle, you're going to put 60 milliliters of sand, so 4 tablespoons again. In the third bottle, we're going to put 60 milliliters of potting soil, 4 tablespoons of potting soil. In the fourth container, we're going to put 60 milliliters of the soil with clay. Notice how the soil with clay is clumped together, so it will be harder to measure with the measuring spoon. You will have to break it up a little. I will add 100 milliliters of water to each container and time it for 1 minute. Let's see how much water is collected in the bottom of the container for each type of soil. Use your science journal to record your data. At the top of the sheet, I've written "just passing through." That's the name of the science experiment. I've also put that this is the amount of water I've collected after 1 minute. So for the gravel, after 1 minute, we collected 93 milliliters of water in the bottom of our catchment basin. For sand, we collected 26 milliliters of water. For the potting soil, we collected 80 milliliters of water. And for the backyard soil with clay, we collected 72 milliliters of water. Which of the soil samples allowed the most water to go through? The gravel had 93 milliliters of water passing through, so it had the most. Which of the samples allowed the least amount of water to pass through? Sand had 26 milliliters of water, so it allowed the least amount of water to pass through in 1 minute. Another way to show your data in your science journal is to make a data chart. In the first column, I've noted the soil type: gravel, sand, potting soil, or soil with clay. In the second column, you will notice I've used 60 milliliters of each soil sample. That amount has to stay the same in order for us to compare the different soils. The last column shows how much water was collected in the bottom of the catchment basin. How much water went through the soil in 1 minute. And you can see that gravel has 93 milliliters, sand has 26 milliliters, potting soil has 80 milliliters, and soil with clay has 72 milliliters. Notice I included a fifth column. This is where your comments and observations would go. Now that we've completed the experiment, we can consider some other questions. Where would be the best place to build a building? What types of crops will grow best in a particular field? Will the basement of a house flood when it rains? How can the quality of the groundwater in the area be improved? These questions can be researched and new experiments can be designed as we continue to learn about the importance of soil moisture. This activity aligns with the next generation standards, the standard on earth materials and systems, and the standard that includes the role of water in Earth's surface processes. How do the properties and movements of water shape Earth's surface and affect its systems?
Thanks for watching this NASA STEM EPDC Quick Bit. Don't forget to check out the description below for more information and links.